Hello students, in previous class we discussed the various properties connected with an electric charge, okay, and out of the various properties we are discussed about the discrete nature of the charges, that is q equals to Ne, okay, conservation of charge, that is in an isolated system total charge remains constant, additive nature of charge, that is the total charge of any system is the algebraic sum of all the charges present at different point of that system, and the transfer property of the charge, okay, and the nature of force, okay, that is like charges repel each other and unlike charges attracts each other, okay. So in this class we discuss the some of the important terms connected with the electric charge, okay. So out of the some important terms we can say, generally we divide when we observe an electric charge, generally we find in a electric charge, so that is some important points connected with electric charge, okay. What are the different important points? First thing we can say that is a electronic charge, okay. First is electronic charge, okay. Electronic charge means we can say it is the smallest amount of charge that exists freely, and we generally say that is the fundamental quantum of charge, okay, fundamental state of charge. Electronic charge means it is the fundamental charge, and generally we take the electronic charge as electron, okay. So it is the amount of electronic charge means we can say it is the charge or the amount of charge which is present in an electron, okay. The charge of an electron is known as electronic charge, okay, and generally the charge of the electron in magnitude form, charge of electron will be 1.59 into 10 to the power minus 19 coulomb or 1.6 into 10 to the power minus 19 coulomb, okay. So that is the electronic charge. Second thing हम कहूचे, that is the negative and positive charges are equal in magnitude, that means charge of electron and charge of proton are same, okay. Though electron is negative, proton is positive, but both the charges possess same amount of charge, okay. So did you get the point? What is an electronic charge? An electronic charge is equal to the amount of charge exists in an electron, okay, and its value will be 1.6 into 10 to the minus 19 coulomb, and the magnitude of negative and positive charge are equal, understand. Second hame कहूचे, what is a point charge, okay. Electronic charge पर हमें गोटे another concept नवा point charge. What is a point charge, okay. So generally we represent a point charge as Q, okay. We generally represent the point charge as Q, okay. What is a point charge, okay. A point charge we can say, a point charge is a charge whose magnitude is very small, okay. A point charge is the charge whose dimension is very small as compared to the distance up to which its effect can be observed, okay. Simply we can say a point charge is a charge whose dimension or magnitude is very small, okay. So the charge having very small magnitude or dimension is known as point charge, and oftenly we represent point charge as small q, okay. And when there is a number of point charges exist in a system, you can mention there q1, q2, q3, q4 like this, okay. So a point charge is generally a charge whose dimension or whose magnitude is very small. Okay. Third thing I say, when we consider, okay, when we consider the different charge system, okay, like different charge system means we can say that is either a air system or a water system or any other system. Okay. And when we measure the effect of charge from one system to another system, then we find there is a variation between the different system of charges. Okay. That means when we observe the effect of charge in air and when we observe the effect of charge in water, there is a difference between air and water. Okay. And that difference is known as permittivity. Okay. Permittivity means we can say it is the characteristics of the medium which determines the capacity of the charge. Okay. The characteristics property of the medium, it means we can say that is the variation in the effect of the charges between the different mediums. Okay. Either we may take the effect of charge in air, another we can take a effect of charge in water, another we can take effect of charge any other medium. Okay. And when we differ from medium to medium, its value also changes. Okay. So that's why there is a comparison factor arises, and that comparison factor is known as permittivity. Okay. And generally we represent permittivity as epsilon. Okay. But when we measure the absolute permittivity, it is generally taken as epsilon 0. Okay. So absolute permittivity means we can say it is the permittivity in free space. So absolute permittivity is the permittivity in free space, and generally we represent at epsilon naught. Okay, or epsilon 0, you can say epsilon 0 or epsilon naught. Okay. So absolute permittivity means permittivity in a free space, and the measurement of permittivity in free space will be given as epsilon naught equals to 8.85 into 10 to the power minus 12 10 to the power minus 12 Coulomb square Newton inverse meter to the power minus 2. Okay. So that is the characteristics property of any medium, and if that medium is free space, then it is called the absolute permittivity, and it is represented by epsilon naught. Okay. Another things we say relative permittivity. Okay. We discuss in more details after observing the units. Okay. When we discuss Coulomb's law, I just only say what are the different terms. Okay. We discuss later in brief. Okay. Relative permittivity, there is another word that connected with charge, that is relative permittivity. That is epsilon r. Okay. So epsilon r, that is the permittivity, variation of permittivity between two mediums. Okay. So if we make a comparison of the permittivity between air to any other medium, then that comparison is known as relative permittivity. Suppose I take any other medium, permittivity in any other medium is epsilon. Okay. Permittivity, suppose C medium, that is permittivity in a medium, epsilon naught permittivity in free space, and when we make a comparison between that medium to the free space, and that term is called relative permittivity. Okay. And that relative permittivity is the ratio of permittivity in a medium to the permittivity in free space. Okay. So, relative permittivity will measures the variation or the variation in strength or effect of charge between a medium to the free space, okay, and that term is called relative permittivity. So, relative permittivity is the variation of C medium, or simply we can take that is permittivity epsilon by epsilon naught, okay. Epsilon r, that is relative permittivity, equal to epsilon by epsilon naught, or epsilon equal to epsilon naught epsilon r, okay. So, permittivity of any medium is the product of permittivity in free space to the relative permittivity. So, these are the different terms that are connected with charge when we observe the Coulomb's force, okay. So, now take the observation towards Coulomb's law, okay. Coulomb's law in scalar form, okay. So, first when you observe the effect of charge upon another, then Coulomb first observed that when we take two different charges towards each other, or when we take the charges away from each other, there is certain effect act in between the charges, okay, and that certain effect is known as force, okay, and that force is known as Coulomb's electrostatic force, okay. And when we take two different charges, suppose I take two different point charges, okay, one point charge is q1 and another point charge is q2, two different point charges q1 and q2, and suppose both the point charges are separated by some distance r. If we separate, the point charges may be positive, may be negative, okay. So, depending upon the nature of charge, we can find the either attractive force or the repulsive force. So, Coulomb first take two different point charges and separate the point charge to a certain distance. Suppose we take the distance as r, okay, and when the charges are observed, then there is a force act in between the two charges, okay, and if we measure the force, then we find the magnitude of the force, okay. Suppose F is the force experienced in between the two charges q1 and q2, and the magnitude of the force is directly proportional to product of their charges, okay. And if we measure the force in between the two charges, then we find the force experienced between q1 and q2 separated by distance r is directly proportional to product of their magnitudes, okay, product of their magnitude of the charge and inversely proportional to square of separation between them, okay. The force that experience in between the two charges always varies inversely to the square of distance between the charges, okay. So, that is why if we place two charges very close to each other, they experience a large force, and when we take the two charges away from each other, they experience a small force, okay. So, there is a inverse relation, the inverse relation in force with the distance, okay, and since r is in the order of negative minus 2, so that is why it is called inverse square law, inverse square law. Since force is inversely to the square of separation between them, so we can say this law is also known as inverse square law, okay. So, what does the Coulomb's law in electrostatics says, okay. So, Coulomb's law in electrostatics says the electrostatic force between two electric charges is directly proportional to product of their charges and inversely proportional to the square of separation between them, okay. And if we combine both the effects, okay, we find F proportional to q1 q2 divided by r square, okay, F proportional to Q1 Q2 by R square, okay. So here we can write F equal to some constant, suppose I take that constant as beta, okay. So beta Q1 Q2 by R square, okay. So what is beta? So beta equal to proportionality constant or force constant. So beta is a proportionality constant or force constant, but beta depends upon nature of intervening medium. Okay. So beta depends upon the nature of intervening medium or nature of medium in between the two charges, okay. So beta we take as proportionality constant, or simply we can say that is the force constant, but nature of beta depends upon the medium between the two charges, okay. That means we can say the value of beta varies when we change the medium from when we change the medium, okay. So now let us look what does the beta takes when we change the different mediums, okay. So if we observe the value of beta, okay. So generally the value of beta, suppose I take this one is equation 1, okay. So the value of beta generally changes from medium to medium, and if we measure in different system of units, suppose I take value of beta in SI system, okay. So in SI system the value of beta for any medium, okay. So value of beta for any medium, that will be 1 by 4 pi epsilon, because we say epsilon is the permittivity of a medium, okay. So beta equal to 1 by 4 pi epsilon, but we discuss epsilon equal to epsilon naught epsilon r, okay. So that's why this can be written as 1 by 4 pi epsilon naught epsilon r, okay. So if we take the force in that medium, okay, so that will give 1 by 4 pi epsilon naught epsilon r Q1 Q2 by R square. So that will be the value in any medium, okay. So SI system we can say beta equals to 1 by 4 pi epsilon, okay, or 1 by 4 pi epsilon naught epsilon r, and if we substitute the value of beta here, then we find F medium equal to 1 by 4 pi epsilon naught epsilon r Q1 Q2 by R square, okay. Second thing is very important, when we measure the relative permittivity of any medium, then we name the relative permittivity as dielectric, okay. Another important thing is that we can represent epsilon r as k, okay, and that k is called dielectric constant, okay. So if we replace epsilon r by k, so what we change? So F medium will be 1 by 4 pi epsilon naught k, okay, epsilon naught k Q1 Q2 by R square, okay. So dielectric medium means we can say that is the variation of the effect of charge in between the two mediums, okay. Variation of effect or the capacity of the charges in between the two different medium is known as relative permittivity or dielectric, okay. So F medium will be 1 by 4 pi epsilon naught Q1 Q2 by R square, okay. But if we consider AR, okay, relative permittivity of AR or free space, relative permittivity of air or free space, or we can say dielectric. Okay, so that will be epsilon r equals to k equals to 1. Okay, for air the dielectric constant is 1, for air the relative permittivity is 1. So that's why if we consider force in air, so what we get, if we convert medium to air, then the relative permittivity will be 1. Okay, so if you substitute here k equals to 1, or here epsilon permittivity is 1, so force in air that will be 1 by 4 pi epsilon naught q1 q2 divided by r square. Okay, so that is the force between two charged particle when the medium in between them is air, then force will be 1 by 4 pi epsilon naught q1 q2 by r square. Okay, because for air medium beta. Okay, so here if epsilon equals to epsilon r equals to k equals to 1, then beta will be 1 by 4 pi epsilon 0, and that is for air. Okay, so for air beta equal to 1 by 4 pi epsilon 0, and for medium it is 1 by 4 pi epsilon. Okay, so that's why force in air equal to 1 by 4 pi epsilon 0 q1 q2 by r square. That is the Coulomb force between the two charges when the medium in between the charge is air. Okay, second aspect is called the CGS system. Okay, so generally in CGS system the value of beta is taken as 1. Okay, when you substitute all the magnitude value of the charges, then value of beta will be 1. Okay, so if value of beta equal to 1, force equal to q1 q2 divided by r square. So that will be the force between the two charges when they are placed in a CGS system. Okay, understand? Now, if we take the calculation of the value of beta, then we can calculate beta depending upon the value of permittivity. Okay, as I say, value of beta is 1 by 4 pi epsilon naught, or if for a medium 1 by 4 pi epsilon, or 1 by 4 pi epsilon naught k. Okay, so if you substitute the corresponding values, then we can calculate the value of beta. Okay, so in next class we will discuss what is the actual value of beta in a mathematical form, okay, or in a calculation value of beta with respect to other medium. Okay, and what are the vector form that Coulomb's law take, different vector form of the Coulomb's law. Okay, we discuss in the later class. Okay, thank you.